If theta minus pi equal to pi by 2, then show that cos square theta, cos theta sin theta, cos theta sin theta, sin square theta, cos square pi, cos pi sin pi, cos pi sin pi, sin square pi. The product of the square matrix, we can show that it is equal to 0. See here, first what they have given that theta minus pi is equal to pi by 2. From this, theta is equal to pi by 2 plus pi. Here we can take cos theta on both sides. Cos theta equal to cos of pi by 2 plus phi. It is in the second quadrant. Second quadrant cos is negative, that is minus sin pi. Again sin theta equal to sin of pi by 2 plus pi. It is equal to sign in the second quadrant is positive, then it is the cos phi. Okay. By using of these relations, if it is cos theta, then cos square theta is equal to squaring on both sides, then it will becomes the sin square theta. For the sin square theta, squaring on both sides, then it is the cos square pi. It is sin square pi. Okay, it's minus into minus plus. Now we can change. Here, cos theta, sin theta can be changes into cos and sin pi angles. So cos square theta, we can write it as sin square theta. First, we can take it is LHS. LHS is equal to square matrix cos square theta, cos theta sin theta, cos theta sin theta, sin square theta into cos square pi, cos pi sin pi, cos pi sin pi, sin square pi. It is equal to in the place of cos square theta, we can write it as sin square pi. Cos theta is minus sin pi, sin theta is cos pi. It is also minus sin pi, cos pi. Sin square theta is nothing but cos square theta, cos square pi into cos square pi, cos pi, sin pi, cos pi, sin pi, sin square pi. Product of these two matrices. It is equal to row into column sin square pi, cos square pi, minus into plus minus sin square pi, cos square pi, row into second column sin cube pi, cos pi, minus sin cube pi, cos pi. Second row, first column, minus sin pi, cos cube pi, plus cos cube pi, sin pi, cos square pi into cos pi, sin pi. Again, it is minus sin square pi, cos square pi, plus cos square pi, sin square pi. The same terms with negative sign. So it is equal to 0, 0, 0, 0. It is equal to 0. It is RHS. Therefore, LHS is equal to RHS. Fourth problem, give examples of two square matrices A and B of the same order for which AB equal to 0 but BA is not equal to 0. Here we can take two square matrices with the same order and the product should be equal to 0 if AB, but we can multiply the order is change BA, it should not equal to 0 we can take. We can take the square matrices. Let the square matrices be, one is A is equal to 1 1 0 0 and B equal to 0 0 1 1. Just you can check it. AB, AB product is row into column. It's 0 0, okay. Row into column, it should be 1. So this is not suitable. 1 0 0 1 0 1 1 0. Now we can multiply. It is also no. 1 1 0 0 0 0 1 1. Row column 0, row column 0, row column 0. Okay, it is possible. If we take the AB product 1 0 1 0, B is 0 0 1 1. The product of these two matrices 0 plus 0, 0 plus 0, 0 plus 0, 0 plus 0, it is equal to 0. Next we can take BA is equal to, B is 0 0 1 1, A is 1 0 1 0. Product of this, it is equal to, it's 0, this is 0, 1, 1s are 1, 1 1s are 1. Next it is 0, it is equal to 0 0 2 0. This is not equal to 0. Therefore, AB equal to 0 and BA is not equal to 0. We can choose the two square matrices. Those product will be 0 for one case. On which matrices the product is 0, we can choose in that way. Here the first element is non-zero, 0, 0, non-zero. Non-zero, 0, 0, non-zero. Then alternate means it will get the product is 0. This is the solution of the given problem. Fifth problem, a trust fund has to invest 30,000 rupees in two different types of bonds. The first bond pays 5% interest per year. The second bond pays 7% interest per year. Using matrix multiplication, determine how to divide 30,000 rupees among the total types of bonds. If the trust must obtain an annual total interest of 1800 rupees, first case, second case 2000 rupees. First we can take total amount, how much amount they are paying, how much interest they are paying. Given invested amount by trust fund equal to 30,000 rupees in two types. How many types? Two types of bonds. The first bond, the rate of interest is interest of first bond is equal to 5 percentage. Interest of second bond equal to 7 percentage. We are taking in the first bond, they are investing X rupees. Let rupees X be invested in first bond. Be invested in first bond. And in 30,000, we can subtract X rupees. Then it is the invested in the second bond. And in the first case, the annual total interest is, in the first case, the annual total interest is equal to 1800 rupees. Okay. Here we can take in the matrix form. Matrix form means X amount for first bond, 30,000 minus X is the amount of the second bond into 5 percentage of the interest in the first bond, 7 percentage of the interest in the second bond. The multiplication of the matrix, that is the row into column, adding of this, we are getting the amount is 1800 rupees. The left side is also that is in amount only. So product of this 5x by 100 plus 30,000 minus x into 7 by 100 is equal to 1800 rupees. Taking the LCM, 5x plus 7 3s are 21, that is 2,10,000 minus 7x whole by 100 is equal to 1800 rupees. 5x minus 7x is minus 2x plus 2,10,000 rupees is equal to 1800 rupees into 100 rupees equal to 1,80,000 rupees. This 2x is taking to right side. It will be 2x is equal to 2,10,000 minus 1,80,000. Then 2x equal to 0, 0, 0. It is also 0. It's 2 cancel. 11 minus 8 is 3. So x equal to 30,000 by 2. It is equal to 15,000 rupees. So invested in first bond equal to 15,000 rupees. Invested in second bond equal to 30,000 minus 15,000 is equal to 15,000 rupees. Okay, it is the first case. For the second case, same as usual only. In the second case, x 30,000 minus x, rate of interest 5 percentage, 7 percentage is equal to 2,000 rupees. Again product 5x by 100 plus 30,000 minus x into 7 by 100 equal to 2,000 rupees. Taking the LCM, 5x plus 7 3s are 2,10,000 minus 7x equal to 2,000 into 100. LCM and cross multiply. Minus 2x is equal to 2 lakh minus 2 lakh 10,000 x equal to minus 10,000 by minus 2 equal to minus minus cancel 5,000 x equal to 5,000 and 30,000 minus x equal to 30,000 minus 5,000 equal to 25,000. Therefore, invested in first bond equal to 5,000 rupees. Invested in second bond equal to 25,000 rupees. It is the solution.
R2 minus.
Here, such type of the questions, just you can observe. If any one of the column having the ones unit elements, then in that you can keep one row is as it is. R1 is R1 only. Then R2 and R3 rows can be eliminated to 0. That is nothing but R2 into R2 minus R1, R3 into R3 minus R1. You can do the transformation or operation, elementary operation with a one row only. What you are keeping constant, that is same as it is, then you can operate the another two rows with that row only. Okay, now you can check it. Modulus of the first row we can take as it is BC, B plus C, 1. Next R2 minus R1. R2 is BA, R1 is B minus BC, C plus A minus of B plus C, 1 minus 1. Next AB minus BC, A plus B minus of B plus C, 1 minus 1. So it is equivalent to BC, B plus C, 1. Here in these two, B is common, A minus C. Here, plus C minus C get cancelled. You are getting A minus B. It's 0. From this, B is taking common, A minus C. And here also plus B minus B get cancelled, A minus C, 0. Now you can take the determinant. This BC into AD minus BC 0, B plus C into AD minus BC is also 0. So it is equal to 1 into determinant. The corresponding row and column eliminated, we can take B into A minus C, A minus B, B into A minus C, A minus C. Okay, it is equal to B into A minus C into A minus C minus B into here AB minus BC. Here A minus C. BA minus BC. AB minus BC. B common. Here B common. Okay. B into A minus C into A minus B. In these all, B into A minus C is common. The remaining somewhat is, it is not BA, it is CA. This is CA. Why? Because we cannot get the same values. Here it is CA minus BC, AB minus BC. Here C is common, A minus B, B is common, A minus C. Here C is common, C is common, A minus B. Here also C into A minus B into A minus C minus B into A minus C into, it is also getting C. It is minus C, A minus B. So minus B, A minus C. Okay, it is A minus B, A minus C, A minus B, A minus C. So A minus C, A minus B common from the two terms. A minus C, A minus B common, remaining C minus B. So what they are asking, the order B minus C, C minus A. It is equal to first A minus B, in the next minus common C minus A, in the next minus common B minus C. Minus into minus plus equal to A minus B into B minus C into C minus A. It is a solution. The matrices problems are taking more time when we can take the direct determinant. So in that case, we can use the operation, row operation. See here, observe that here in this B plus C is there, here A plus B is there. But what we can do? Suppose we can subtract from this to this, again we are getting the two terms. But we can reduce to lesser terms, means just you can observe the R3, A is there, here A is there, B, B, C, C. When we can take R3 into, it's not R3, R3 is a single, R3 into R3 only, R2 is R2 minus R3. Then A minus A cancel, B minus B cancel, C minus C cancel. Again, we are getting B, C, A here. After that operation, again, here B is there, B is there, C is there, C is there, A is there, A is there. Again, we can take R1 is R1 minus R2. So, the each and every row getting the single terms only. From that, we can easy to find the determinant. So that is the idea. First, R3 is R1 and R3 write same as usual. That is determinant. B plus C, C plus A plus B, A plus B minus A, B plus C minus B, C plus A minus C, A, B, C. It is equal to determinant. A cancel, B cancel, C cancel. B plus C plus A plus B, C, A, C. Again, R1 into R1 minus R2. So, the determinant is B plus C minus B, C plus A minus C, A plus B minus A, B, C, A, B, C. It is equal to A cancel, C cancel, B cancel. Determinant CAB, BCA, ABC. So the single terms means we can easy to find the determinant. It is equal to C into C into C square minus AB minus A into BC minus A square plus B into B square minus AC. It is equal to CQ minus ABC minus ABC plus AQ plus BQ minus ABC. It is equal to AQ plus BQ plus CQ minus ABC minus ABC minus ABC minus 3ABC. It is the RHS. See here, determinant y plus z, x, x. Here yz is there. If we can take R1 into R1 minus R2 minus R3, then it is reduced to 0. Okay, it is minus z minus x minus z. Minus 2z will come. Here also minus y, x minus z. It is the more than two terms, that is three terms. It is 0 means we can take the determinant if the one coordinate, one row value is 0 means we can take another two yz, then AD minus BC, AD minus BC, it will get the easy. Okay, just at least 1 0 or single terms. If there in the 3 by 3 matrix, then the simplification of the determinant is very easy. So you can reduce to that way. Okay. Ax, by, cz, x square, y square, z square, 1, 1, 1. We can show that A, B, C, x, y, z, y, z, zx, xy. See here LHS. In the LHS part, just we can observe here. In the first column, if it is multiply and divide with x, x we can take. Multiply and divide with y, multiply and divide with z, then it becomes 1. So that is ax, by, cz, x square, y square, z square. 1 can be written as x by x, y by y, z by z. So in the first column, we can take x common. In the second column, we can take y common. In the third column, we can take z common. Then it becomes ax by x. Okay. Common means we can write a, b, c, x, y, z, 1 by x, 1 by y, 1 by z. Is it clear? So this xyz is multiply with only last column. Determinant a, b, c, x, y, z, x, y, z by x, x, y, z by y, x, y, z by z. So it is equal to determinant a, b, c, x, y, z, x, x cancel, y, y cancel, z, z cancel, y, z, x, z, x, y equal to RHS.